All right, hello everyone. So today we have a calculus problem. Find the equation of the tangent line at the point 1, 1, lying on the equation 1 plus natural log or ln of the quantity xy squared plus y cubed equal to x squared minus cosine of quantity pi x. All right, so the first thing we're going to assume here is that y is a function of x. We're working with an implicit derivative, essentially, in so many words. Here, we're not told that one function is a variable of the other, but when it's not that case where you're not told, we're going to assume that y is a function of x. Okay, and that technically is very important in order for us to take a derivative and apply all our derivative rules. Okay. Sometimes they'll state like which function is dependent on which of the variables. So it could be technically like x is dependent on y. Usually they would state that, but if it's not stated, then you're assuming that y is going to be a function of x. So essentially what that's going to imply for us is that anytime you take a derivative of something involving y, you're going to have dy dx or y prime next to that term. We'll get to that more in a second. All right, so let's go ahead and get started with this. So the first thing we have to do is find the slope of the tangent line, which is, how do I find that? I take a derivative. So I'm gonna start by taking the derivative of both sides. And as you see right here, let me apply that in blue. And what I did was I used properties of derivatives. Derivatives are, say, linear operators, which means that you can take the derivative of each individual term. So I broke it up in a way on both sides. And let's go ahead and take our derivatives now. So on our next line, we'll go ahead and do that. The derivative of 1 is just 0 because it's just a constant. For the derivative ln of xy squared, I have to use the chain rule because it's a composition of functions. I would have 1 over xy squared. So I took the derivative of the outside function, which is ln, which would be 1 over whatever's on the inside, times the derivative of the inside. And for that inside, you have xy squared. You have to use a product rule. So begin by holding x and taking the derivative of y squared, which would be 2y, y prime. So again, anytime you take the derivative of anything involving y, we're going to put a y prime next to it, plus we're now going to hold the y squared and take the derivative of x, which is just 1. So that's that part done. And that'll be the more complicated part of this problem. For the next part, the derivative of y cubed, so that would be 3y squared y prime equals, on the other side now, 2x plus, and why is it plus? Because I'm taking the derivative of cosine pi x. It's a chain rule. And the derivative of cosine is a negative sign. So it'd be sine pi x, but you have to take the derivative of the inside, which will result in a pi. Okay, so you need to stop for a second and try that out. I'd recommend that. So we've got our derivative now, and now we will plug in our point. Okay, there's another way of doing this, which says, you know what, you ought to try to solve for the y prime because technically that's what we're looking for. So y prime equal to etc. So certainly you can do that. However, that's going to involve quite a bit of algebra here, as you can see. So what I'd rather just do is plug the points 1 and 1 for x and y into where I see them. So it'd be 1 times 1 squared, 2 y prime plus 1 plus 3 y prime equals 2 plus pi sine of pi. If you simplify this out, this would be 2y prime plus 1, because this whole thing is just equal to 1, this part right here in red that I just wrote, plus 3y prime equals 2 plus 0, because the sine of pi is 0. So you'd have 5y prime equals 1. So what I did was I added all the like terms together with the y prime, so it'd be 5y prime. Then I moved everything over. And in general, what you have is when you're working with this method, when you're trying to solve for y prime, you need to get all the y primes on one side and everything else on the other and get y prime by itself. So we had 5y prime equals 1, and all you needed next was divide by 5, so we got y prime equals a fifth. And that is the slope of our tangent line, m. And now I'm going to go ahead and get my equation going, and there's a few things that are written out there on how you do that. My preferred equation to write out is the point slope form. So in our case, my points are 1 and 1 for x, and my slope is a fifth. So there you go. That you can go ahead and work with that as your final answer. You could also add 1 to the other side and distribute that 1/5 would give us a total of 1/5 x plus 4/5 after you do a little bit of distribution with the 1/5 here. And there you go. So either one of these equations would work out. Most of the time it's written with these two forms that you see right next to the asterisks. So just to reiterate, when you're given finding the equation of a tangent line at a particular point, lying on a curve, you will go ahead and take a derivative of both sides, and anytime you take the derivative of y, you're going to put a dy dx next to it. And you would plug the points in like I did, or solve algebraically for y prime and then plug the points in. And whatever you get there is your slope. Okay. Well, thank you for your time. Hope this helps.